Hello dear students, today you are going to learn about distance and displacement. So you have to know what is distance, what is displacement. You observe here. You observe here, when a body travels from initial point A to final point B. Okay, this is initial point and this one is final point. So what is distance? You observe here. The total length of actual path traveled by a body between initial and final positions is called distance. So what is distance? The total length of actual path traveled by a body between initial and final positions is called distance. What about its SI unit? This SI unit is equal to meter. What about this SI unit? This SI unit is meter. That can be represented as small letter m. Okay. What about this symbol? Symbol of meter is small letter m. And this distance is a scalar quantity. What about scalar quantity? What about scalar quantity? A quantity which has only magnitude but no direction, that is known as scalar quantity or scalar. For example, Rama traveled 64 kilometer. 64 kilometer is the magnitude, but it has no direction. So that's why distance is a scalar quantity. Okay, do you understand? And distance is always positive. Distance is always positive. Okay. Now, what about displacement? You observe. What about displacement? You observe here. The shortest distance between initial and final positions of body is called displacement. Its SI unit also. What about this SI unit? This SI unit is also meter. What about this symbol? Yeah, small letter M. Displacement may be positive or negative or zero. Okay. Now you observe displacement is a vector quantity. It is a vector quantity. What about vector? What about vector? A quantity which has both magnitude and direction and follow the laws of vector addition is known as a vector. Okay, so that's why displacement is a vector. For example, Rama traveled 64 kilometers towards east direction. So here 64 kilometers is the magnitude and east direction. So that's why it has both magnitude and direction. That's why displacement is a vector or vector quantity. Okay, do you understand? So that is the difference between distance and displacement. You observe here. Okay. Now you observe applications of distance and displacement. First application you observe. Application. Application 1 you observe. When a body moves along curved path, then you observe this is initial position, initial point, this is final position or final point. When a body moves like this, when a body moves along curved path from initial point A to B, from initial point A to final point B, then what about distance? What about displacement? What about distance? You observe here, when a body moves along curved path from initial point to final point B, like this. What about distance? What about displacement? So distance here, this distance which is greater than displacement. That is one application. And also you observe application 2. When a body moves along a straight line from A to B, you observe like this, from A to B along straight line. Then what about distance? What about displacement? Here distance is equal to AB and displacement is also AB. So that's why then distance is equal to displacement. Okay? You observe. You observe here. You observe both these conditions. Distance which is greater than displacement. Here, in this case, when a body moves along a straight line from A to B, you observe then distance is equal to displacement. Distance AB is equal to displacement AB. Okay? Distance AB is equal to displacement AB. Both are equal. And another application you observe. Application 3. You observe when a body moves along a circle from P point to P point, from P point to P point. You observe here, this is circle. Here you observe, body moves like this. When a body moves along circular path or circle from P point to P point, then what about distance? What about distance? What about displacement? You observe here. Here displacement becomes 0. How displacement becomes 0? Here, when a body moves along circular path from P point to P point, displacement becomes 0. There is no displacement. Displacement is equal to 0. What about distance? Distance is equal to, what about distance? What about distance? What about distance? Distance is equal to here circumference of this circle. What about circumference of circle? So distance is equal to circumference of this circle. So body moves here from P point to P point along circular path. So that's why distance is equal to circumference of this circle. What about circumference of circle? 2 pi r. Okay, do you understand? Displacement, when a body moves along circle from P point to P point, then displacement becomes 0 and distance is equal to circumference of the circle, that is equal to 2 pi r. Do you understand here? And another application you observe, another application. Another application. Okay, another application you observe. When a body moves along a semicircle, from A to B, you observe there, you observe like this. This is A, this one B. So here when your body moves along a semicircle from A to B, then what about distance? What about displacement? Tell me. So tell me, what about distance here? So distance is equal to, so in the case of semicircle, distance is equal to 2 pi r. What about in the case of semicircle? 2 pi r divided by 2, that means pi r. You will get pi r, semicircle. Okay? 2 pi r divided by 2. 2 to get cancelled, you will get pi r. Distance is equal to pi r. That means distance is equal to circumference divided by 2. But here semicircle, 2 pi r by 2 means here 2 to get cancelled, you will get pi r. Next, what about displacement? Displacement is equal to AB. So that is equal to r plus r, 2r. So displacement is equal to 2r. Okay? Right? Do you understand?